Hope everyone's having a good Saturday so far. Okay, cool. I think I'm gonna get started. All right, well, hi everyone. So as you can see by the title of the slide, we're gonna be talking about the Google Cloud Platform today. A little bit about me is my name is Sana. I'm a third year computer science student at Carleton University. I'm also a production engineering intern / dev degree intern at Shopify. And I also help run the GDSE chapter at my school. I'm the vice president, and I also worked on the 30 Days of Cloud. So back in October, a couple of GDSEs got together and worked on this thing called 30 Days of Cloud because we wanted to invite other people to learn about the cloud and what it was. So we have a whole website, and if you want to connect with me on LinkedIn, feel free to scan this. I'll also be sharing my slides after. So if you missed this code, don't worry, you can connect with me later. So today we'll basically be going over what GCP is, how you can use GCP, a little bit of a demo of GCP platform and Cloud Shell, and how you can use GCP for your solution challenge. So what is GCP? So to learn about GCP, we have to start off by learning about what the cloud is. So a definition by Google is the cloud is a metaphor for the network of data centers which store and compute information available throughout the internet. So the cloud is essentially a service that allows people and organizations to store data on the internet instead of locally. So as you can see in this photo, at the bottom, like this is basically the servers, and it's like big infrastructure that you need. And so instead of doing that, Google Cloud basically lets developers build and host their applications and websites, store data, and analyze data on the Google's computing infrastructure. So Google does most of the heavy stuff, and all we have to do is like load our data onto the cloud. So the power of cloud also changes the way that we work by automating these processes and enabling real-time collaboration between people from all across the world. So what is cloud computing? Cloud computing basically has 5 fundamental attributes. First, customers can get computing resources on demand and self-service. So cloud computing customers use an automated interface and get the processing power, storage, and network they need with no need for human intervention. So basically, you can get it whenever, wherever. Second, they can access these resources over the network from anywhere in the world since it's available on internet, like I mentioned. Third, the provider of these resources has a big pool of them, and so they can allocate them to customers out of that pool. So this allows the provider to get economies of scale by like buying in bulk, and customers don't have to know or like really care about the exact location of those resources. So essentially, like Google, they have a bunch of these resources for us, and it's available all across the world. And whenever we want resources, we just ask for them, and then they give to us. Fourth, the resources are elastic. So similar to the concept of elastic demand, elastic means that the customer, whenever they need more resources, they can get it. And then whenever they need less, they can scale back. And finally, the customers basically pay for what they use or reserve as they go. So if they stop using the resources, they stop paying. And the good thing about it is that if you're signed up for the solution challenge, you'll get like, I think $200 worth of credits. So you don't have to worry about like necessarily paying, but you can use that allocated money. So the reason that many use cloud computing for their applications is because its goal is to provide both the input and the output data and generate a trained algorithm that will recognize input and output that you will give and then it will give you the corresponding output. So as you can see in this diagram, you have like the input, you have the output, and you have an algorithm. And then essentially you're like training the algorithm so that whenever you give it a different input, it will give you an output. So its concept is pretty common in machine learning. Next, we'll be watching a video on cloud storage.
Give me a minute and I'll show you how cloud storage can help you store objects while optimizing the performance of your apps. Google Cloud Storage is a global, secure, and scalable object or blob store for immutable, unstructured data such as images, videos, and documents. When you are building an app, you store objects in buckets, which are associated with a project. You can then upload objects to the bucket and download objects from it using the console or gsutil commands. By default, data at rest is encrypted, and you have options to secure it with your own encryption keys. You can grant permission to specific members and teams, or make the objects fully public for mobile and web applications. When creating buckets, you have options depending on budget, availability, and access frequency. Choose standard regional or multi-regional buckets for high performance, frequent access, and highest availability. Nearline for once-a-month access, cold line for less than once a quarter, and archive for data that you want to put away for years. The objects are automatically versioned, and with Object Lifecycle Management, you can automatically transition the data to lower-cost storage classes when it reaches a certain age or when you store a newer version of the file. Once you have stored the data, accessing it is easy with a single API call for all the storage classes. Cloud storage is optimal to use for hosting static websites, streaming, and storing documents. It is widely used for backups and archives, and it is a great data lake choice for big data and ML. Next time you're thinking about storing data, take a minute and look at cloud storage. For more info, check out cloud.google.com/storage.
So now that we've learned about the basics of cloud and what it is, let's learn about the Google Cloud Platform. So GCP in one sentence is a service that you can store your data, host applications in the cloud in a secure and protected location. So it's a public cloud vendor that offers computing services to do everything from data management to delivering web and video over the web to AI and machine learning tools. Customers are able to access computer resources hosted in Google's data centers around the world for free or like pay per use, like I mentioned before. So people basically run code and store data on Google's infrastructure while Google sets up the servers, and we click a couple buttons to host it on there. Cloud is definitely still a new technology, but over 900,000 companies worldwide host their applications on the Google Cloud Platform, and you can do that too. So we still need to cover a couple more definitions. So we have infrastructure as a service, we have software as a service, and platform as a service. Infrastructure as a service is the on-demand availability of scalable computing resources as services over the internet. So instead of basically the user just needs to manage the operating system and the application while Google handles the rest. And you just pay for what you use. An example is Google's compute engine that we will also be covering soon. Software as a service are software products that run on Google Cloud and are built by Google. And the user here will just supply the data. So another example is Google's compute engine. I mean, not compute engine, Kubernetes engine. And then finally, platform as a service is a managed service where the user provides the application. So sorry, the definitions are a little wrong on this, but I will fix that. So for example, you have Firebase that we will also be talking about. And then Google Cloud divides the world into 3 multi-regional areas. So you have Americas, you have Europe, and then you have Asia Pacific. Regions are independent geographic areas that consist of zones. And so a zone is a deployment area for Google Cloud Platform resources within a region. So this is especially helpful when you create like a virtual machine because you need to place that virtual machine somewhere around the world, preferably close to you so that you get the resources from somewhere. Zonal resources operate within a single zone. And if a zone becomes unavailable, all the zonal resources in that zone are unavailable until the service is restored, which is why it's really important for like larger organizations to deploy your applications across multiple zones in a region to help protect against that. Google Cloud Platform's services and resources can be zonal, regional, or even managed by Google across multiple regions. So currently Google has about 17 active regions around the world. How do you use GCP and why you should use it? So before we jump into the demo, a couple other things that we need to cover are like GCP functions. So you have compute, you have storage, networking, Stackdriver, tools, big data, and AI and ML. So there's a lot that you can do with GCP, but essentially compute is you can run code, you deploy code to the cloud, and you run it on the cloud. Storage is like it says, data storage and databases options for structured or unstructured, relational or non-relational data. You have networking, which is basically manage, connect, secure, and scale your networks, and also balance application traffic and provision security rules. And Stackdriver is used for DevOps, so like Kubernetes. You have tools, which are services that help developers manage deployments and application build pipelines. Big data is basically services that allow you to process and analyze large data sets. And finally, artificial intelligence. So there's some pre-trained algorithms that you can use from Google, or you can build and deploy your own machine learning models. So here are some examples. So for compute, you have like compute engine, Kubernetes engine, app engine, cloud functions. For big data, you have BigQuery, Dataflow, storage, like Cloud SQL, and then machine learning, you have like the natural language API, the vision API. And we'll see all this on the actual Google Cloud platform. And the next thing we have to cover is creating projects in Google Cloud. So essentially for creating, enabling, and using all Google Cloud services, including managing APIs, enabling billing, adding and removing collaborators, and managing permissions for Google Cloud resources, you need a project. So a project has a project name. So like anything you want to name it, has an ID, which is like a global unique identifier for your project. You have a number, which is automatically generated. And essentially you organize all your Google Cloud resources into this project. And you can use it for like virtual machines, a set of databases, a network that connects it all together. And also has settings and permissions, so you can like set security rules and also rig roles. And this is what a Google Cloud Platform looks like. And I will be walking through this, but this is like basically what you will see. There's a lot going on, so we'll cover this. And to interact with GCP, you have 4 different options. So you have the Google Cloud Console, which I just showed you. It's the web user interface. You have the SDK and Cloud Shell, which is the command line interface. You have mobile apps, which is available for iOS and Android. And then you have APIs, so you can make your own custom applications. I'm just going to stop sharing my screen there. I'll stop here for any questions, but everyone can just go to this link and hit get started. Okay. So here we have the Google Cloud Platform. I'll just give it a couple of minutes so that everyone can get into here and just, get started, log in if they need to. I'll give you guys about 2 minutes, so till 3:19. Well, seems like no one really has any questions, so I'll just get started. So when you get to the Google Cloud Platform, yours may not look like this just because I'm in a project, but you can create your own project by selecting at the top, and you can click New Project. And you can name it anything you want, so I'll just name it whatever they've given me. You can create a project, and once that's been created, you can go into that project. And especially projects are used for like larger companies because there's a lot of things that you can do with it. But here's like the dashboard. You have like the name, the number, the ID, like I mentioned, and these are all the resources that you have. And if you use any APIs, you'll see like how many requests per second that you have, You can monitor, you can create, like you can look at your analytics. So here you'll see you have like the compute engine, storage, APIs, like I mentioned. And so let's go to view all products. So like I mentioned, the 7 functions that GCP has, you have compute, storage, networking. In compute engine, you can like create a VM. You can have the Kubernetes engine. So there's a lot of things that you can do here. But let's go to IAM and admin, which basically means identity and access management. And we can go to roles. So especially when working with GCP, it's really important to have different roles for your project. So you can create a role, and essentially you can have like a viewer, you have an editor, owner, because you don't want to give too much access to one person if they don't need it, or like too little access to one person. So you can go through that. And also, especially, we have APIs and services. So let's go to library. And one thing that you might want to use for your solution challenge is called the dialogue flow API. If you just search for that. It's used for conversational applications. And so you can just enable that, and you can use it whenever. So again, like if you see here, this type is a software as a service. So something that I mentioned earlier. And once you enable that, you can use that in your project. And another API that we will enable is called the compute engine. This one we can use to in the Cloud Shell that we have. So this button over here activates our Cloud Shell. So we can just go ahead and click that. So this Cloud Shell works like a regular terminal. You can access information about your project. You can create VMs. So one thing that we'll be doing once this loads up is we'll be creating a VM through our Google Cloud Shell. And VMs again are just used as like a different like mini computer almost that you can run things in, and you have all the resources that cloud gives you. This is taking a little bit, so I'm just going to switch to a project that has it already. And then there's this command. I will post this command, but this command will essentially create a VM for you using the shell. But there are 2 ways that you can create it. So either you can use the shell, or you can just go into compute engine, go to VM instances, and create an instance. So either way works, but this one you have like you're creating a lab name, you have a name, you have a machine type that you're specifying. So machine type really depends on how much like power you need for what you're working on. And then also the zone, like I mentioned, like there's different zones around the world that Google has. So we can just go ahead and that. So as you can see here, it like created the VM. And if I reload this page, then I should see it. Well, once you create it, it should show up here, and then you can using the internal and external APIs, you can access its resources and use it. So I'm going to stop here and wait for any questions that you have or anything that you want me to go over again. There's definitely a lot of other things that you can do, like in your case for your solutions challenge. For if you want to use like a database or something, you can use the cloud storage to do that because there's like SQL commands and all that stuff. In the meantime, I will go back to my presentation. So to end off the presentation, I do have a couple of resources that you can use. So for your solution challenge, one thing that might be especially helpful is hosting on Firebase. So hosting your web application so that it's totally free, and you can connect it to the Google Cloud platform. So I have a link on how you can host on Firebase. There's some Google Cloud commands that you can use for your Cloud Shell. Some more videos on like the intro to GCP, things that I haven't specifically covered. So I'll probably go in more detail on the APIs and services that you might need, the compute engine resources, and there's also the Google Cloud Essentials pathway. So with your cloud credits, you can get some certifications and also just learn more about GCP and how you can use it. So that is all I have for today. Feel free to ask me any questions, or if you want me to go over something, I can definitely do that. So I did mention Firebase, and to access your Firebase console, you can use this link. And essentially, Firebase is, if you haven't heard of it, it's basically a hosting platform. So I've used it to host my personal website, and you essentially can monitor analytics. You can see how many people are looking at your website. You can see if you want to use a database, you can also use it on there. So this is where the connection between Firebase and cloud comes in. You have like all these resources that you can use, and especially for your solution challenge, it'll be helpful. But that is all I have for today. Thank you so much for coming. I hope you guys learned a lot about Google Cloud Platform, and good luck on your solution challenge.